Right, okay. All right. All right. Right. All right. Okay, now can someone right. Okay. Right. All right. So then, I think we have done our first recap class. I think 1.5 week before, and today we are doing our second recap class. Right. Then last day I gave a kind of start up. I think I started dimension sections. And then we started linear motion unit 2. At unit 1 dimension section I started, and unit 1 linear motion section I started because it's very important, because currently in our main theory class, in our current theory class, we are doing projectile motion. I think projectile motion theories we completed. These days we are doing questions. So therefore, we should quickly, we should cover the previous sections, and we should adapt to our current lessons, right? You should be able to understand what I am teaching in current our main theory classes. Therefore, I am giving priority. I am giving priority to unit 2 sections. That's why I started last day unit 2 linear motion. Today we are continuing that linear motion remaining sections as soon as possible. And we are doing some questions today. If it is possible, we'll give a small try to start unit 2 vertical motion also. We'll give a small try. Most probably after completing vertical motion, definitely you can understand current theory classes for sure. Right? Then stay focused and be active. Right? Any doubts, if you want to clarify anything, you can reply to Sulaiman sir in the Zoom chat. Feel very comfortable. That's what I can tell. Right? Any doubt you can put in your Zoom chat, then I will respond for sure. Right? Okay. Now last day I think I explained main story. I explained what does it mean by an object is at rest, what does it mean by object is under motion, right? And that stories we learned last day. Okay? All right. Okay. So now remember now, when studying about motions of object, we are assuming our earth is stationary. But last day I told you actually our earth is not stationary object. It is rotating around own axis. But I told you, assume when studying motions of objects on the earth, we are assuming our earth is stationary, but actually not stationary, but we are assuming our earth is stationary, right? Okay. Now when studying motion of any object, we require some physical quantities. Last day I explained what is a physical quantity. Last day I explained nicely. Therefore, I am not going to explain what is a physical quantity today. So what are the physical quantities that we require to describe a motion? Definitely, we need time. Without time, we can't explain a motion. Every motion consumes some time. What else? To describe object's motion, time is one of the important physical quantity. What would be the other physical quantities we require? Definitely displacement, distance, and then velocity, and then acceleration and speed. So now we are prioritizing, we are going to talk about, yeah, we have learned in all levels, distance, displacement, speed, velocity, acceleration, these stuffs you also learn in all levels, but for understanding, we are learning in A levels also. So therefore everyone quickly put your main topic, distance. Put your main topic, distance. Put your main topic, distance. Right me? Distance. Main topic, distance. Now symbol for distance is simple d, right? Symbol for distance is simple d, distance. Distance. Symbol is simple d. Right? Now what is distance? What is that exact idea? So now let's say now there's an object. That object is maybe a car, maybe a person, right? It can be any object. Let's say now initially when t equals 0, initially means we are assuming t equals 0, time is 0, right? Initially that object is at point capital A something. In the beginning that object is at point capital A. Now with the time this object is under motion. When you track the path traveled by this object, this would be the path traveled by this object. Okay, finally after traveling along this path, after simple t time later, this object reaches a point capital B. Point capital B after traveling simple t time. Okay, right? Okay. Distance is nothing but when you track behind this object along the path that this object travels. If you're measuring the length of the track, length of the path traveled by the object, that is what we are calling as distance. Right? When you measure the length of the path traveled by the object, that is what we are calling as distance. So very clear, this length of the path is we are calling as distance. Clearly? So if I use a different color, okay? If it's a different color, right? Distance means length of the path traveled by the object. The length of the path traveled by the object is we are calling as distance. This green color length is distance, simple d, distance. Okay, distance. Then what are the units of distance? We all know that SI units to measure distance. We can measure distance in meters, kilometers, centimeter. Likewise, there are so many units to measure distance, but mainly standard international SI unit to measure distance is meter, right? So then units, SI units of distance, that is meters. That is meters, simply. And last week, first recap class, I explained that how to find the dimensions of physical quantities. Then tell me what would be the dimensions of distance. Very clear. Distance dimension is capital L. We learned last week. To show the dimensions of distance, we are writing the simple d inside a square bracket. If you write simple d inside a square bracket, anyone understands? That is basically dimensions of a distance. Right? If you write down inside a square bracket simple d, the meaning is dimensions of distance. Dimensions of distance, that is equal to capital L. The next story we all know that distance does not have a particular direction. Therefore, distance is basically a scalar. So write down under distance, write down the length of the path traveled by an object. Just write down the length of the path traveled by an object is called the distance. The length of the path traveled by an object is called distance. Distance. And in this diagram you can draw, and units of distance in meters, dimensions of distance capital L, distance is scale. This diagram and these points quickly put in your notebook, Right, soon do it. Any doubts, ask. Right, okay. Right, okay. Then next story. Right, okay. Next idea. Next idea. Now, right, okay, next we require now another physical quantity that is somewhat similar to distance but not exactly, completely different. That is displacement. Displacement. What is displacement? Displacement. Displacement symbol is capital S. Displacement symbol is capital S. Symbol capital S, displacement. Capital S. Now, let's say now same example. Now object is initially at point capital A. It travels along this path and reaches point capital B after simple t time. Same example I am taking to explain what is displacement. Now in that story, if I explain same story, initially object is at point capital A. It travels along a path like this, file reaches point capital B. Reaches point capital B. After simple t time later, right? Initially object is at point capital A, right? Okay. Now displacement means, remember, the shortest distance between initial and final point. The shortest distance between starting point and final point is we are defined as displacement. Then remember, the displacement is always the shortest distance between initial point and final point. Let's say now point capital A is our initial point. Point capital A is our initial point. Initial point. And point capital B is our final point. Point capital B going to be our final point. Then what would be the shortest distance between initial point and final point? Very clear. That's going to be a straight line drawn between initial point to final point. Right? Remember the straight line drawn from initial point to final point. That's going to be the displacement. But remember, straight line drawn from initial point to final point, not from final point to initial point. From initial point to final point, straight line drawn is displacement. Displacement. Right, remember the straight line drawn from initial point to final point, that is what we are calling a displacement. Symbol is capital S. Displacement. Right, displacement. Now displacement is also a length, therefore SI units of displacement is meters. So you can write down SI units of displacement is meters. SI units of displacement is meters. And since displacement is also a kind of length, dimensions of displacement is capital L. Dimensions of displacement is capital L. Dimensions of displacement is capital L. That is capital L. And remember, displacement has a direction, always from initial point to final point. Therefore, remember, displacement is basically a vector. Very important to remember, displacement is basically a vector. So now what shall we do now? Quickly, just put your subtopic displacement, symbol is capital S. Write down this definition, write down. The shortest straight line between the shortest straight line between initial point to final point. The shortest straight line between initial point to final point is defined as displacement. Then this diagram and this story quickly put in your notebook. Then very clear distance displacement idea we can understand. What shall we do? Based on this idea, we will do some questions. They will understand more about distance and displacement. Then we'll talk about velocity and speed. Right? Next story. Now, if I share a PDF in the group, all right. If I share a PDF in the group, then right, okay. All right, okay. Okay. Right, okay. I'll share a PDF. Right. Okay. Right, okay. Right, okay. Okay. I'll share in the groups. Right. Now in that PDF, start doing, go to the page number. In the PDF, go to the page number. Page number 3, start doing question number 1, test me question number 1. Page number 3, start doing test me question number 1. Find the distance and displacement done by the object when it moving from A to B. Start doing page number 3, question number 1, give a try. Can do, not difficult, anyone can do, easy. Can do. Anyone can do, easy, not difficult. Anyone can do. Right now, okay, now test me question number 1, page number 3. Page number 3, test me question number 1. Test me question number 1, start doing them. Test me 1. Test me question number 1. Right, okay. Then first one, they are telling what? First one, number 1. Then simple A. Test me question number 1, simple A. Find the distance and displacement. Object is moving from A to B. Then, right, okay. Right, in that case, keep on doing. Not difficult, anyone can do these questions. Then we talk about speed and velocity. Then we talk about average speed and average velocity. Then that's all. Right, then initial point is point capital A. Then this is point capital B. This angle is 90. This point is point capital C. Right, then so this point is point capital B. This point is point capital B. Right. Now they have given now this vertical distance given as 8 meters. 8 meters. This horizontal distance given as 6 meters. Then if you want to find the total distance traveled by the object is traveling from A to B along this path. Total distance is very clear, 8 plus 6, 14 meter. Total distance, simple D, that's going to be equal to 14 meter. What about the displacement? Displacement is always measured from starting point to final point. Starting point is point capital A, final point is point capital B. If you draw a straight line connecting starting point A to final point B, that's going to be a displacement. Right, direction is starting point to final point. When you find capital S, Pythagoras theorem. Right angle triangle, Pythagoras theorem. Then we can write down hypotenuse is capital S. Then we can remember capital S squared. If not capital S, that is equal to, if you can remember Pythagoras theorem, 8 squared plus 6 squared entire root. Then 8 squared is 64. Answer is 10 meters only, but I will do the simplification properly. 8 squared is 64 plus 6 squared is 36 entire root. 64 plus 36 is 70 plus 30 100. Root 100. Root 100 means we all know displacement is exactly 10 meter. Displacement is exactly 10 meter. Capital S is exactly 10 meter, right? Then when you go to simple B, if you go to simple B, now that diagram, initially object is at point capital A moving 10 meter to the right side direction. That object moves 10 meter to the right side direction, 10 meters, and then that object is coming back to the left side direction. After traveling 10 meter right side direction, it turns and travels back to the left side direction. A distance 2 meter. Right? Finally, this is point capital B. This gap is 2 meter. This gap is 2 meter. This gap is 10 meter. Right? Then they are asking total distance travel means initially object goes to the right direction 10 meter and from here to here 2 meters. Total distance traveled is exactly 12 meter. 12 meter. Displacement means starting point to final point. Remember always displacement means remember starting point to final point. The shortest straight line distance. Starting point to final point. A to B. This distance is displacement. Then we are getting this capital S is 10 minus 2, that is 8 meter. Capital is going to be 10 minus 2, 8 meters. 8 meters. So then likewise we can do few more questions. Simple C part. Simple C, now they have given a semicircle. Object travels along a semicircle. Third one, object travels along a semicircle. Semicircle story. Semicircle, very simple story, anyone can do. Right, people who finish the stories quickly. Now we are doing somewhat faster, but I will explain all the theory points properly, don't worry. But I'm going somewhat faster because it's important, right? Because our target is somehow adapt to the current theory classes, to understand what's teaching in current theory classes. That's our plan, right? Okay. Now simple C part, a kind of semicircle is there. A semicircle is there, right? Semicircle is there. Right? Okay. Alright. Then radius of this semicircle is given as 7 meter. Radius 7 meter. Radius capital R is how much? 7 meter. That object initially at point capital A traveling along this circular path reaches finally point capital B. Point capital B. Radius capital R that is given 7 meter. Radius 7 meter. Then if I want to find the distance traveled by the object from A to B, I should find the circular path. We can remember all level science we learned an equation to find the perimeter. If not circumference of a circle, to find the perimeter, if not circumference of a circle, the equation is what? If you know the radius, perimeter, if not circumference, the diameter is capital D, radius capital R. If I ask you diameter in terms of radius how much? Tell me diameter in terms of radius capital R over 2. Capital R over 2 capital R. Diameter means twice the radius. Right? And the next important equation is we know circumference, perimeter. Let's say symbol we can use capital P. Perimeter means capital P. That is equal to 2 pi R. 2 pi R. If not, you can remember all levels perimeter means in terms of diameter. Right, pi into 2R, 2R is diameter, pi capital D. This story you learn in all levels. But this equation 2 pi R is to find the total perimeter, total circumference of the entire circle. But currently we are having half of the circle. Therefore, we all know that we should divide total perimeter by half to obtain the circular path distance. Very simple. Then total distance traveled is how much? 2 pi capital R into half. 2 pi capital R into half. Substitution. Then 2 into pi means we can remember all level signs. Pi means there are two now same value only 3.14 decimal value. If not pi, all level we learned that 22 by 7. 22 by 7 mostly now you can apply any value for pi, but better if you can substitute instead pi, if you can substitute 22 over 7, better 3.14 also possible, no issue, can apply, no issue. 2 into 22 over 7 division into radius is 7 meter into half. That is your simple D. When you subject simple D, that is equal to how much? This 7 and 7 cancel out. You can divide these to 2 also, you can cancel out. Then we are getting finally, that is 22 meters. Clearly? That's clear. And displacement means initial point to final point, the straight line distance, the radius 7 meter. That means this gap is 7 meter, this gap also 7 meter. From the center to any point on the perimeter, it is the radius, no? This gap is also radius 7 meter, and this gap also radius 7 meter. Then what is the straight line distance between starting point capital A to final point B? That is 14 centimeter. So displacement capital is going to be 14, my bad, meters. 14 meters. That story. So now we have a kind of good understanding, right? We know what is distance displacement ideas. Okay, all right. Now likewise, we'll give a small try. Simple D is possible if it is a complete circle. Okay, yeah, good. We'll do simple C. Simple C, we can learn one important point by doing simple C, simple D part. By doing simple D part, we can learn a kind of new point. A simple D, they have given a complete circle. A complete circle. Radius, the radius is 21 meter. Radius 21 meter. Capital R is 21 meter. Initially, object is at point capital A. Remember, starting point is point capital A. This object travels along the circular path and finally reaches the same point. Finally, object reaches the same point. Remember, starting point is point capital A. Object travels along the circular path and finally it reaches same point. Right? Then, if you want to find the total distance, when you find the total circular path circumference, that's going to be total distance. Therefore, total distance is equal to how much? 2 pi r. 2 pi radius capital R, then 2 into pi means 22 by 7. Radius going to be 21 meter. Then when you simplify, you are getting the answer. You can divide 7 by 7, 1. If you divide 21 by 7, that's going to be 3. Then 22 into 3 means 66. 66 into 2 is how much? That's going to be 132 meters. Simple, it is how much exactly? That is 132 meters. Simple, it is exactly 132 meters. That is okay. What can you say about the displacement? Remember always displacement means the straight line distance between starting point and final point. The straight line distance between starting point and final point is displacement. Now in this scenario, sir, initially also object is at point capital A. After travel the distance, finally also object is at point capital A. Then since the starting point and final point are same, displacement of the object is 0. Very important point. Displacement of the object is 0. 0, very important point. Very important point. Okay. Then we can write an important point as a note. Write down. If the starting point and final point are same, then the displacement of the object is 0. then the displacement of the object is 0. Then the displacement of the object is 0. Okay, alright, okay. So then ideas, okay, you can try remaining questions, you can try the remaining questions. Okay, now I have done 4 questions, now very clear what is distance and what is displacement. Story is overall okay, story is okay, right? Then next story. Now we have 2 more questions in that part. Point simply part also can do if you want. Right, no need. Simply part also almost same idea. I explained the entire theories properly. Right, okay, done, enough. Right. Now we can talk about speed and velocity. Speed and velocity. Next story, speed and velocity. Right, any idea about speed? Remember, speed, all levels also we learned. Speed means the rate of change in distance. If not rate of change in distance, if not change in distance per unit time, that is what we are calling a speed. Right? But if I explain this way, look here. Now I have an idea. Look here. Right. All right. Now story. Speed. Symbol is simple V. Speed. Symbol is simple V. Now we can tell speed means rate of change in distance. But some people don't understand. So what do you mean by rate of change in distance? We don't understand. Now very clear, when object is under motion, we all know. When this object is under motion, we all know. With the time, distance it travels gonna increase. When the object, with the time increases, distance traveled by the object gonna increase, right? Initially object is at here, the time is 1 second, the time is 2 seconds, object will be somewhere there, the time is 3 seconds, object will be somewhere there. They are very clear. With the time, distance traveled by the object gonna increase, no doubt, no doubt. Now we are telling, let's say for an example now, there's an object. This object is traveling, let's say simple d distance within simple d time period. Initially A, this object is traveling simple d distance within simple t time period. For an example, within 5 seconds, distance traveled is 20 meters, for an example. Within 5 seconds, distance traveled is 20 meters, for an example. Then we can tell, okay, sir, within simple t time period, distance it traveled is simple d. Then, sir, what should be the distance it travels in 1 second? Within simple t time period, distance it travels is simple d. Within 1 second, what is the distance it travels? That is how much? For example, within 5 seconds, it travels 20 meters. For 5 seconds, it travels 20 meters. 1 second, what is the distance it travels? That's going to be how much? 5 seconds, 20 meters means 1 second distance it travels is going to be what? That's going to be very easy. 5 chocolate, 20 rupees means 1 chocolate how much? 5 chocolate, 20 rupees. 1 chocolate how much? 4 rupees. 4 rupees, 4 meters. Then within 1 second time period, what is the distance it travels? That is what we are calling as speed. Remember what is speed? Speed is, remember, distance traveled by the object within 1 second. Distance traveled by the object within unit time. Unit time is, remember, always 1 second. 1 second. That is we are calling a speed, symbol V. So we can write down. We can do a small simplification. Look at in simple t division 1, that is equal to what? Simple d over v. Simple d over v. When it's subject v, you can cross multiply. Vt equals 1 into d. The t into v, that is going to be equal to 1 into d. Small simplification. Simple t into v, that is going to be equal to 1 into d. Alright, that is simple D. 1 into simple D means simple D. When it's subject V, we can write down a nice story. Speed is nothing but distance over time. Distance over time, right? So we can write down the first equation. Remember, speed means, right, distance over time. Speed means, remember, distance over time. Distance, division, time, distance over time. Speed means, remember, distance over time. Speed means, remember, distance over time. Alright. You must remember this equation, one of the important equations. Right, okay. Then, sir, if I write this equation in symbolic way, speed is simple V, then distance is simple T. Speed equals distance simple T, time taken simple T. Then speed equals distance over time, V equals simple dot, important equation. Important equation in the MCQs they can ask you. What is the units of speed? What is the dimension of speed? Speed is vector or scalar. They can ask some questions like that in your A-level MCQ paper. They can ask in that story. In that case, what we can do? Right. In that case, what we can do? All right. In that case. All right, this story is also okay. Right, then we'll do questions, don't worry, we'll do some questions also. Then we'll complete what is velocity as well. Then we can do some questions. Right, okay. Right, okay. Now then what can you say about the units of speed? So distance measured in meters. And time is measured in seconds. Then meters over second, m over s. When second comes to numerator, that becomes what? M s to the power minus 1 meters per second. So very clear. The units of speed is, that is what? Meters per second. M is minus 1. M is minus 1. You have to write down units of speed, M is minus 1. We can write down then. Units of speed, that is m is minus 1. And next point, remember, speed is a scalar, right? Units of speed is m is minus 1. Units of speed, remember, m is minus 1. Then remember, speed is a scalar. Dimensions, what about the dimensions of speed? Right, okay. Sir, if I want to find the speed dimensions, that is equal to what? That is equal to speed equal distance over time. Then speed dimensions equal to what? Dimensions of distance over dimensions of time. Clearly? Dimensions of distance over dimensions of time. That's clear? That's clear. Distance dimensions, that is capital L. Last day we learned. That is capital L. Right, then capital L. What is the dimensions of time? That is capital T. When capital T comes to numerator, that becomes capital T to the power minus 1. Therefore, remember, speed dimensions, that is LT minus 1. Speed dimensions, that's going to be LT minus 1. LT minus 1, right, okay. The next story, remember, speed is a scalar. The next story is, remember, speed is a scalar. We'll do a question. Right, before coming to the questions, till now, okay, we talked about distance, displacement, and then we talked about speed. Right, then we'll talk about velocity. Now, distance is linked with distance. So, my bad. Speed is linked with distance. Very clearly, speed is linked with distance. When it comes to velocity, that is linked with displacement. Right? Remember, velocity is linked with displacement. Okay? Velocity is linked with displacement. Then what is velocity? We can tell velocity means the rate of change in displacement. If not, we can write down velocity means change in displacement per unit time. Change in displacement per unit time, that story. That means again we can talk Right now, if you haven't written definition of speed, write down like this. If you haven't wrote this definition of speed, write down like this. The rate of change in distance. The rate of change in distance. The rate of change in distance, or write down change in distance per unit time. 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 Change in distance per unit time is called, change in displacement per unit time is called velocity. Velocity. Sorry, I was telling speed. Okay, my bad. The rate of change in distance or change in distance per unit time. Change in distance per unit time. Okay, please cut. If you wrote something like displacement, cut it. Change in distance per unit time. Change in distance per unit time is called speed. It's an entire story. Right? Okay. Right? Okay. Then we'll talk about velocity idea. If we talk about velocity, then velocity, right? Velocity symbol is capital V, right? Again, imagine now light. Now an object is moving in a straight line. If an object moves in a straight line, initially at point capital A, finally at point capital B, when you measure displacement from initial point to final point, that's going to be capital S. Displacement is capital S. Time taken to achieve capital S displacement is, let's take the simple t. Clearly? Now we want to understand what is velocity. What is velocity then? Velocity means, remember, so within simple t time period, displacement done by the object is capital S. Within simple t time period, displacement done is capital S. Within 1 second, within unit time, displacement done by the object is what we are calling as velocity. Within simple t time period, displacement done is capital S. Within 1 second, displacement done is we are calling as the velocity. Velocity. Simple, 5 chocolates, 10 rupees. 1 chocolate, how much? 2 rupees. In order to find the price of 1 chocolate, you should divide 10 over 5. 5 chocolates, 10 rupees. 1 chocolate, how much? 10 over 5. 10 over 5. 10 over 5 means 2 rupees. That means to find the velocity, we know you should divide displacement by time. Very simple story. All level maths. Capital S over capital V. When I substitute capital V, that's going to be equal to what? S over T. S over T. S over T. Right, velocity means you want to understand displacement over time. So we can write the equation. Velocity means, remember, velocity means displacement over time. Equation, velocity means displacement over time. Displacement here. Displacement over time. Right, then equation wise, if I write the equation velocity, the equation velocity going to be velocity equals displacement is capital S, time taken simple t, V equals S over T. V equals S over T. S over T. Again, units displacement unit is meter, time measured in seconds. Therefore, units of velocity also remember that is going to be meters per second. M is minus 1. Clearly, units M is minus 1. And remember dimensions. Dimensions also same as LT minus 1. Why? Displacement dimension is capital L and time dimension is capital T. Therefore, remember dimensions of velocity is also going to be LT minus 1. Dimensions, that's going to be, remember, velocity dimensions, that is LT minus 1. Capital L, capital T minus 1. But remember this time velocity is a vector. The important points remember regarding velocity is a vector. Velocity is a vector. Velocity is a vector. Vector, very important point. That's all. That's all. That's all. Now, sometimes in the questions, they might give speed velocity in kilometers per hour. Okay. Look here next story, right? Override is okay. Distance, a summary. Summary is a distance means the length of the path traveled by the object measured in meter. It's a scalar, diameter is capital A. And displacement is a kind of short straight line connecting initial point and final point. Initial point to final point. The shortest straight line distance measured from initial point to final point is going to be the displacement. The units meter, diameter is capital L. It's a vector. Vector. Speed means change in distance per 1 second. Units m is minus 1, diameter is Lt minus 1. It's a scalar. And then velocity means change in displacement within 1 second. Therefore, velocity units m is minus 1 and its dimension is going to be lt minus 1. It's a vector. This is the overall summary. Overall summary, right? Ideas okay. Ideas okay, right? Clearly. Now drink some water. We'll drink some water. We'll drink some water. Right? We'll drink some water, then we'll do some questions. We'll drink some water and we'll do some questions. Right, time is 11:20. Come at 11:25. Come at 11:25. A small water, drink some water, come at 11:25. All right, okay. So then we'll do questions, okay? Time is up. Right, distance, displacement, speed, velocity, 4 stories finished. We can do some questions. Now go to the PDF. In the PDF, right, in that PDF, what you can do quickly, we'll go to question number, page number 8, we'll go to question number 2, 3. Page number 8, we'll do question number 2 and 3. Question number 2 and 3. Page number 8, question number 2 and 3. If we do it, let's do it. All right, in that case. Right, okay. So now, page number 8, question number 2. Really basic question. Now they are telling now an object moves 200 meter distance in 2 seconds under uniform speed. 200 meter distance in 2 seconds. All right. Find the speed of the object. We want to find the speed of the object. Right. We can remember speed equation we learned. Speed equals distance over time. Then speed equals distance over time. Then 200 meter distance given, d is given 200 meter within time is given 2 seconds. Time is given 2 seconds, then we can write down speed is how much. The speed is, that is 200 over 2, that's going to be how much, 100 ms minus 1. Speed is 100 ms minus 1. Clear 100 ms minus 1. Clear. Right. Then question number 3, next story. Now quickly we are doing. You also grab everything very quickly and somehow try to understand current lesson. Right, our target is complete linear motion right now. Anyone can understand? No? Anyone can understand, okay? Right, you are not late, huh? You just started. It's been around 2 or 4 months only finished. Even you are joining within, you also completely all right. We have around 2 years for the exam. Therefore, I am doing this recap classes to support you, right? To get the maximum benefit from these classes and somehow adapt to the current classes. Right, you are not too late. Don't think like, okay, class started 4 or 5 months before me. Now I think after 5 months will I able to understand? Yeah, you will understand. You will able to understand. Yes, right, because remember now you need to just only started. If you understood linear motion and vertical motion, some theories, you can understand anything. Right, and this week, I think today our main theory class, Saturday, Wednesday. Today our main theory class, today at 6 p.m. we are starting a new chapter, motion graph. That's completely new chapter. It's all about graphs. Therefore, you don't require even projectile motion, linear motion, vertical motion under gravity, or vectors or units or dimensions or any theories you don't require. It's a new section, completely new section. But better if you have a kind of small understanding about what is distance and speed and velocity, more than enough. This knowledge more than enough to understand today's lesson. Right? Okay. Now we can talk about question number 3. Next story. Next idea, number 3. Number 3 very easy. Normally when they give the distance in kilometers and times in minutes, normally we convert them into meters and seconds. Normally we keep the final answer for speed or velocity in meters per second. As a practice, normally, generally, we can keep in kilometer per hour also. We can keep in kilometer per minute also, no issue. But as a practice, we are keeping in terms of meters per second as a practice, okay, distance over time. This time, they have given what? They have given object traveling at a constant speed travels 3 kilometers in 2 minutes. So you know, all your knowledge, how do we convert kilometers into meters? When displacement distance is given in kilometer, how are you going to convert into meters? Want to multiply by 1000. Should multiply by 1000. Right, remember, somewhere write down, should multiply by 1000. And then you know how to convert meters into kilometers. Very rarely only they are asking you to convert meters into kilometers. Generally they are asking in the distance, if the distance is given in kilometers, they will ask you to convert to meters normally. That's the normal case. And sometimes they can give you time in minutes. Right, how do you convert a time given in minutes into seconds? You want to multiply by 60. If the time is given in minutes and if you want to convert to seconds, you should multiply by 60. 60. Then sometimes in some questions they can give you time in hours. H-O-U-R, hours. Then they will ask you to convert time in hours into seconds. In that case, you want to multiply by 3600. In that case, you want to multiply by 3600. 600. This story kind of additional story, but all levels also you learn, no? All levels also you learn story, right? Okay. Then sir, distance in kilometers, 3 kilometer, time taken 2 minutes. How do you convert 3 kilometers to meters? Multiply by 1000. 1000 division, time taken is 2 minutes. Then to convert minutes into seconds, multiply by 60. 60. Then we can find the answer for speed. This V is equal to how much? Division. I can divide these two zeros, cancel out. If I divide 3 by 3, 1. If I divide 6 by 3, that's going to be 2. We are getting 100 over 2 into 2 is how much? 4. Denominator 2 into 2, that's 4. 100 over 4, that's going to be 25. That is 25 ms minus 1, 100 over 4, right? Okay, clear? Now clear, idea is okay, speed, theory, idea clear, and we have done some questions. And sometimes remember units of speed, look here. Sometimes kilometer per hour is also remember speed, we can measure speed by using kilometer per hour. Kilometer per hour. In the exams, they can give you speed in kilometer per hour and they can ask you, convert speed in kilometer per hour into ms minus 1. How do you convert? Remember, very important story. When they have given the speed in kilometer per hour and if you want to convert it into ms minus 1, meters per second, then you want to multiply by, remember, multiply by 5 over 18. 5 over 18. 5 over 18. Some people, they say multiply by 1000 over 3600. 1000 over 3600. If you simplify it, if you simplify 1000 over 3600, the simplified version is 5 over 18. 5 over 18. Right? And that story. Then if you want to convert, they don't ask the opposite conversion. In case if they ask you to convert meters per second into kilometers per hour, in that case what you do, multiply by 18 over 5. This is very rare. They don't ask you to convert meters per second into kilometers per hour. They don't ask. In case they ask you, multiply by 18 over 5. 18 division 5. Clear ideas? Okay, right. Then we'll do 1, 2 questions, few more questions. Right, if we do few more questions, right, we'll go to the question number. We'll go to question number, right, okay. We'll go to question number, somewhat good question, not that much difficult question. A somewhat good question. We'll do question number 5. We'll give a small try doing number 5. If you do question number 5, give a small try. Number 5. Now, number 5 question, they are asking what? Number 5. Number 5, they are asking that question. Right, in that question they are asking. In that question they are asking. They are asking a simple story, very simple story. Right, quickly, very simple story they are asking number 5. They are asking A, B and C are 3 points on a straight line. A, B is 5 km, B, C 4 km respectively. A man runs from A to B at a speed of 20 km per hour. Now this time they have given speed in kilometer per hour. We know how to convert it into meters per second if we require. All right. From B to C, speed is 8 km per hour. Normally, remember, as a practice, what you do in a question, whatever the data they have given, please put them into a sketch. Then start thinking. Better if you put the given data into a sketch and start thinking, it would be easier to grab the idea. Right, till you practice enough, follow what I am telling. Draw a sketch. Some people, they don't do that. Draw a sketch, and in the sketch mark all the given data, and also mention the variables we found also. Please mark the variables we found also. Then start thinking, you can grab the idea very soon. If I do that question for your understanding, right, in that story. Right, okay. Now here, this point is, let's say, point capital E, and this point is point capital B, this is point capital C. Now object is moving from A to B to C. When the object is moving between A to B, speed is given how much? Speed is how much? When the object is moving between A to B, speed is how much? That is 20 km per hour. The speed is how much? 20 km per hour. 20 km per hour. Right? What is the distance from A to B? This gap? That is 5 km. Distance from A to B is how much? 5 km. AB equals 5 km. Now when the object is moving from B to C, distance is 4 km. The speed is given as 7. It's 8. B to C at a speed of 8 km per hour. 8 km per hour. 8 km per hour. What they are asking, simple A part, they are asking total time taken. Simply they are asking total time taken from to move from A to C. Right, in order to move this object from A to C, what would be the total time taken? Let's say now time taken to move from A to B, simple T1. Right, shall we find time taken to move from A to B, simple T1 first. Then we'll find again time taken to move from B to C as simple T2. Then what would be the total time? Simple T1 plus T2. That's gonna be the total time. Got the idea? Then what you do? Consider first A to B motion. When you consider A to B motion, apply the equation. Speed equals distance over time equation. Distance over time equation. Speed is 20 km per hour. Right, how are you going to convert 20 now? Sometime, okay, now we can convert 20 km per hour into ms minus 1. That is one option. Right, from the beginning itself, you can convert 20 km per hour into meters per second. You can convert 5 kilometers to meters, and you can simplify it. Okay, we'll do it anyways. How do you convert 20 km per hour into meters per second multiplied by 5 over 18? 5 over 18. Clearly? That is equal to distance 5 kilometer. How do you convert kilometers into meters? Multiply by 1000, 5000. Time taken to move from A to B, we don't know. That's what I'm going to find first. T1. A small simplification here. Now these 5 and 5 cancel out. Right, further I can divide in this 0 and this 0 cancel out. Alright. Then when you subtract simple T1 now. Here look here. I can divide this 2 by 2. If I divide this 18 by 2, it's 9. It's 9. I divide the 2 by 2. 18 if I divide by 2, it's 9. Cross multiplication. I can easily find simple T1 is exactly, balance is 9 is balance here. 100 is remaining here. Therefore, simple T1 is exactly 900. Simple T1 is exactly, remember, 900 simple T1. If we simplify it, simple T1 is exactly 900 seconds. Then try to find simple T2. To find simple T2, we want to consider B to C motion. So can we add together and do it 20 km per hour? Can we add, that's a good question. That's a kind of good question. Now, so can we add together and do it? 20 km per hour and 8 km per hour, 5 km and 4 km. No, remember very important story. Now you very clear, A to C, speed is different. When the object is moving from A to C, A to B, it is traveling in one speed. B to C, it is traveling at another speed. Therefore, remember, throughout the motion from A to C, speed is not same. Speed is changing. If you notice that speed is changing, now A to B one speed, B to C another speed. In that case, remember, you can't add them. Total distance is 5 plus 4 kilometer, 9 kilometer. Then what are you going to substitute speed? Either 20 or 8. So therefore, remember, if the speed is changing during a motion, you can't apply this equation. You want to break down. Like how I broke down. I take an A to B motion. Throughout the A to B motion, object moves on the same speed, 20 km per hour. Then I for the time taken T1 to find B to C motion. Right, this object is traveling on the same speed from B to C. Then I'm going to find the time T2. Then only you want to add them together. Then only you want to add them together. You want to add them together. Right, okay. Give a try, everyone find simple T2. Give a try, everyone find simple T2. Right, give a try, everyone find simple T2. Everyone find simple T2. Next story. Next story, right, okay. Done. Alright, if I find simple T2, let's find simple T2. Then I want to consider B to C motion. If we consider B to C motion, speed is 8 km per hour, distance 4 kilometers. Distance 4 kilometers. Distance 4 kilometers. Right. Okay. Then if I take a B to C motion, I'm applying equation speed equals distance over time. Speed is 8 km per hour. The object is traveling from B to C. Speed is 8 km per hour. How to convert kilometer per hour into meters per second? To multiply by 5 over 18. If I multiply by 5 over 18, that is going to be equal to what? Distance. Distance it travels is 4 kilometer. How am I going to convert 4 kilometers into meters? Multiply by 1000. To convert kilometers to meters, multiply by 1000. When you multiply by 1000, then the time taken is simple T2. Division simple T2. Simple T2. That's a small simplification. Now what can I do? I can divide 4 by 4 1. If I divide 8 by 4 it's 2. Then 2 into 5 gonna be 10, right? When you multiply 2 into 5 it's 10. That 10 gonna cancel out with this 0. When you cross multiply simple T2 is how much? The remaining 18 is remaining here. 100 remains in here. Simple T2 gonna be equal to how much? 1800 seconds. 1800 seconds. In the question they are asking total time taken. Therefore total time taken. Therefore total time taken to travel from A to C. That is T1 plus T2. T1 is 900. T2 is 1800. Therefore total time taken. Total time taken is how much? T1 plus T2. 900 plus 1800. That's going to be equal to 2700 seconds. 2700 seconds. Nice question. Nice story. Now simple B part you guys can't do. Simple B part they are asking average speed, average velocity theories. Now next idea. So now we talked about the velocity. We talked about speed. Now what is this average speed and what is average velocity? Remember, we all know that practically also when you take any object, even you consider our bus also. Imagine the most of a bus. In the beginning, bus is at rest nearby the bus stand. Then bus starts moving. Initially it is at rest. When the bus starts moving, its speed keeps on increasing. Suddenly, bus driver sees a person, right, walking across a road. In that case, bus driver brakes the bus. In that case, speed is again decreasing. Finally come to rest. Again, speed is increasing, decreasing, right? This is how some motions are happening. So speed is fluctuating with the time. Speed is changing. Speed is continuously changing. In that case, we have to define a kind of average speed. Right now, for an example, when you consider your subjects, If you are doing all levels, there are 9 subjects for your all levels. No? Then math subject is your mark is 20. For example, English subject marks 90. Right, then science subject marks is let's say 80. Then in order to your mark is fluctuating, subject to subject your mark is varying. In that case only we are defining kind of average marks to get overall whether you are in a good marks or whether you are in a bad marks. So to get that idea only we are defining that average marks. Then we can understand as an average this person's marks is 60 marks. Then 60 is a good marks. As an average this person's mark is 100. Wow, it's really good. Likewise, why we are defining average when the marks are fluctuating. Likewise, the speed is varying with the time. To be defining kind of average speed. So then put your small topic, average speed, a small topic, average speed. Put a small topic, average speed. Right? Okay. Then what we can do now, average speed, remember now the equation. If we tell the equation, average speed means remember the total distance traveled by the object if you divide by total time. Right? Average speed means the total distance, okay? The total distance. Remember, speed is something else. Average speed is something else. When you divide the total distance object travels, if you divide it by the total time, that is what we consider as average speed. Total distance or total time. Average speed, remember, total distance if you divide by total time. This is what we are calling as average speed. Very important equation. Likewise, what is average velocity? Same idea. When you divide total displacement by total time, that is average velocity. Average velocity means total displacement if you divide by total time. Total displacement if you divide by total time, that is average velocity, total time. That is average velocity, important equations. Now we'll do the simple B part. Okay, question number 5. Simple A part is clearly. Simple B part, they are asking us to find average speed something. As I can remember, they are asking simple B part. They are asking us to find the average speed. Right? Now if you do that story, now when you talk about that story, now average speed equation. Okay, page number 8. Then find the average speed of the journey from A to C. Then sir, average speed equation simple B. That is total distance from A to C. A to B 5 km. B to C 4 km. Total distance from A to C, that's gonna be 5 plus 4, 9 kilometers. Right? Average speed, total distance, that is 5 plus 4, 9 kilometers. To convert to meters, what you want to do? To convert kilometers to meters, multiply by 1000. Division, total time taken we found. A to B time taken is 900 seconds. B to C time taken is 1800 seconds. Total time taken is 2700 seconds. Total time taken 2700 seconds. Then sir here simplification 5 plus 4 9. Then 9000 division 2700. These two zeros cancel out. 0 0. I can divide 27 by 9. If I divide by 9, here I am getting 3. If I divide 90 by 9, I am getting 10. So we are getting around 10 over 3. That's going to be 3.33 ms minus 1 is our average speed. Clearly? Right, okay. Right. This story is okay. Right? Now next story we can talk about acceleration. Right? Put your main topic acceleration. Put your main topic acceleration. Simply. Right? Acceleration simply. Next topic is what? Acceleration simply. Acceleration simply. Acceleration simply. Acceleration. Simply. Now, acceleration means we are defining. You can write down the rate of change in velocity. The rate of change in velocity. Acceleration, write down the rate of change in velocity. Right? If not write down the change in velocity per 1 second. You can write down second definition. The change in velocity per 1 second. The change in velocity per 1 second is acceleration. The change in velocity per 1 second, unit time, whatever, is acceleration. Now look here. Right. Now you are noticing an object's velocity is changing continuously. Right, you are noticing object's velocity changing continuously. For an example, let's say now when the object is at point capital A, its velocity is, let's take it as v1. Now velocity is changing continuously. When the object is at point capital A, its velocity is v1. After traveling delta t time later, if not, after traveling some time, simple time later, to mention a kind of change in time, we are using delta symbol. Remember, delta is a symbol, Greek letter, to represent the kind of change in time. We are using delta. Change in displacement, delta S. Change in acceleration, something, delta simply. Change in mass, delta simply. Delta symbol we are using to show a kind of change in something. Let's say after traveling simple t time, if not delta t time later, the velocity, now I told you this object's velocity is changing. For an example, as it moving on the road, its velocity is changing, like with 5 ms minus 1, 6 ms minus 1, the next second 7 ms minus 1, the next second 8 ms minus 1. Likewise, this object's velocity continuously increasing or decreasing, changing. After delta t time later, let's say this object's velocity is, for an example, v2. Then the change in velocity we can take it as delta v, okay, right? What is delta v? Delta v means, remember, change in velocity. Delta v means, remember, change in velocity. A change in velocity we can write down final velocity minus initial velocity. Right? Delta v means, remember, delta v means you can write down final velocity is v2. This object is traveling from A to B. Final velocity is v2. Initial velocity is v1. v2 minus v1. Clear? Now acceleration means, remember, acceleration means when you consider this much of time, delta t time, 5 seconds, when you consider 5 second time period, the change in velocity of the object is, for an example, 5 ms minus 1. Right? Within delta t time period, the change in velocity of the object, let's take it as delta v. Then when you consider 1 second, within 1 second, what is the change in velocity? Within delta t time period, change in velocity is delta v. Within 1 second, then what should be the change in velocity? That is what we are calling as acceleration. So we can write down acceleration is, remember, that is delta v over delta t. Do you understand? Acceleration is, remember, that is change in velocity over change in time. If you can simplify it, delta t over 1, that's going to be equal to what? Delta v over simply. When you substitute simply, acceleration, that is equal to delta v over delta t. So we can write down the equation. Acceleration is, remember, change in velocity over change in time. Acceleration is equal to what? Acceleration, that is equal to change in velocity over change in time. Over change in time. Acceleration. If you write the simply equals, remember, delta v over delta t. Symbols. Acceleration is simply, that is equal to delta v over delta t. Delta t equation. Clear? Right, okay. Then what is the units of change in velocity? Remember, change in velocity also has same velocity units, meters per second, ms minus 1. Units of time is seconds. Then we can write down units of acceleration as what? Meters per square second, ms minus 2. Right? What about the dimensions of acceleration? So then acceleration dimensions, that is equal to dimensions of change velocity. Dimensions of change in velocity over dimensions of time. Velocity dimensions we all know, that is Lt minus 1. Time dimensions capital T. When capital T comes to the numerator, that becomes capital T to the power minus 1. Therefore remember Lt to the power minus 2. That is the acceleration's dimensions. Remember, very important thing is acceleration is a vector. It's a vector, very important vector. Right? All right. Then remember, one story is very important. Let's say now object's velocities keeps on increasing. Right? Let's say when the time is t equals 0, velocity is 10 ms minus 1. After 1 second later, velocity is 20 ms minus 1. We noticed velocities keeps on increasing. The next second, velocity is 30 ms minus 1. Very clear. Right, in this direction, object is moving right side direction. In that direction, velocity keeps on increasing, means remember, object is under acceleration in that direction. You can mark in that direction, right side direction, you can mark acceleration. Okay, object is under acceleration in that right side direction. Okay, now there is another scenario. Let's say now velocity is changing, but this time velocity of the object is decreasing. Right, let's say object is still moving right side, but object is getting slow. Right, velocity is decreasing, sir, 50 ms minus 1. Now 40 ms minus 1 speed. The next second 30 ms minus 1. The next second 20 ms minus 1. If you notice velocity is decreasing, then we are telling in that direction object has a deceleration. Right, we are telling in that direction object has a deceleration. If not, we can call it as retardation. Then what is the relationship between acceleration and deceleration? Remember, roughly put in your mind, rough understanding, deceleration is always negative acceleration. Okay, now imagine the right side direction, this object's velocity, as the object moves right side, we noticed its velocity decreases 50, 40, 30, 20, 10. Then in the right side direction, object is under deceleration. If you go to the opposite side, 30, 40, 50, velocity seem like increasing. Then left side direction, object is under acceleration. So roughly put in your mind, deceleration means negative acceleration. Kind of important point. Deceleration means, remember, negative acceleration. A kind of small point right down there. Deceleration is kind of negative acceleration. You can roughly think like that. Deceleration is equal, remember, kind of negative acceleration. This point is okay. This point is okay. This point is okay. This is the overall idea. Right? Okay. Now we can talk about, I think till now idea is very clear. Now we can talk about linear motion equations. I will tell you one story. Now so far we talked about speed equation, velocity equation, and then acceleration equation we talked. Now we are going to talk about linear motion equations. Put your main topic, linear motion equations. Very important part. This is what we are talking these days. Very important part. Put your main topic, linear motion equations. Very important part. Linear motion equations. Very important part. Right, okay. Look here. You can apply this equation, speed equals distance over time. If not velocity equals displacement over time, those equations you can apply only when the object is moving under uniform speed, uniform velocity. For an example, if there's a car, that car keeps on moving under same speed, 5 ms minus 1 same speed, you can apply that equation, speed equals distance over time. If a car is moving under same velocity, 20 ms minus 1 continuously, you can apply velocity equals displacement over time equation. But if you notice continuously speed or velocity fluctuating, if you notice continuously velocity of the car, any object is changing, you can't apply speed equals distance over time or velocity equals displacement over time equation. You can't apply. Okay. The reason, right, if you notice an object's motion, if it is a uniform velocity motion, uniform speed, uniform velocity motion, look here, uniform speed, that means constant speed. Uniform means, remember, constant, same speed, constant if not same speed, uniform if not constant, same speed, uniform speed if not uniform velocity, okay, uniform speed if not velocity, then you can apply, remember, these equations you learnt. It's very important, it's very important idea. Then you can apply this equation, speed equals what, distance over time equation. If not velocity equals displacement over time equation, you can apply only when you notice object is moving under uniform speed or uniform velocity. If you notice velocity varying, not uniform velocity, this time it's a variable velocity. If you notice velocity is varying, it's a variable velocity, it's a variable velocity. If it is a variable velocity, then remember we can apply only, but remember there is one condition, velocity is varying and acceleration is constant, okay? Object's velocity varying but acceleration constant, same acceleration constant. Acceleration constant, C means constant, okay? velocity is varying, but sir, throughout the motion, velocity is changing, increasing or decreasing doesn't matter, but acceleration or deceleration must be constant, same. Then we can apply something called linear motion equations. Then we can apply something called linear motion equations. So what is this linear motion equations? What is this linear motion equations? Right, that is our topic now. Clearly, the summary, put in your mind the summary. Now we can talk about linear motion equations. Right, remember, right, summary, okay? Linear motion equations. Linear motion equation. There are 4 equations in our syllabus. Let's say now, sir told that we are applying linear motion equations when the object's velocity changes. Velocity can be increasing continuously or velocity can be decreasing continuously. For example, object's velocity increasing like 5 ms minus 1, 6 ms minus 1, 7, 8, 9, 10. Likewise, velocity can be increasing. Sometimes velocity can be decreasing. Right, 10, 9, 8, 7, 6, ms minus 1, 4, ms minus 1. Likewise, velocity can be decreasing. Right, let's say now this object's initial velocity is simple u. This object's initial velocity is simple u. Acceleration normally simple v. When this object is undergoing acceleration, we all know that velocity keeps on increasing. After traveling, let's say capital is displacement. After traveling capital S displacement, the velocity of the object becomes, let's say, simple v, velocity. Time taken, simple t. The linear motion equation means, remember, the equation which provide relationship between initial velocity u, final velocity v, acceleration, time taken, displacement. That's all. You mentioned, you want to understand what is u? Initial velocity. Initial velocity. Right, what is v? Final velocity. What is v? Final velocity. What is a? Acceleration. Final velocity. What is simply acceleration? Acceleration. What is simply time taken? Time. Capital S going to be displacement. So there are 4 linear motion equations, remember. The first equation is, remember, v equals u plus at. The first equation, v equals u plus at. The first equation. The first linear motion equation is going to be v equals u plus at. Right? The first equation. The first equation is, remember, v equals u plus at. That means final velocity is always equal to initial velocity plus acceleration into time taken. Second equation, displacement is equal to ut plus half at squared. Third one is, remember, v squared, that is equal to u squared plus 2as. Last one is S equals u plus v division to simple t. These are the 4 equations, linear motion equations. Right, ni? Clear? Till now, okay, ni? Now we'll do some questions. Now based on this knowledge, we can do some question. We'll do some basic question. in that PDF, in that PDF, in that PDF, starting, go to the page number in that PDF. You can go to the page number 18, question number 1. Page number 18, question number 1 can do. Now can do. Based on the given data, you want to select the right equation. Now there are 4 equations. Based on the given data, you should select the right equation. That's the way. That's the way. Then page number 18, question number 1 start doing. What they are telling? Now they are asking a train traveling with a uniform velocity 20 ms minus 1 suddenly began to accelerate at a rate of 2 ms minus 2 for 20-second time period. 20 to 20. Initial velocity of the train is 20 ms minus 1. Okay. What I understood is initial velocity of the train is how much? It's 20 ms minus 1. This train's initial velocity, that means u, that is 20 ms minus 1. Acceleration of the train is 2 ms minus 2. Acceleration is 2 ms minus 2. Okay. After 20 seconds later, let's say after 20 seconds later, train is somewhere here. After 20 seconds later, let's say train will be somewhere here. The train will be somewhere here. After 20 seconds later, the train will be somewhere here. Okay. Time is given 20 seconds. 20 seconds time is given. They are asking what? They are asking displacement and final velocity. I want to find the final velocity v and then displacement capital S. Displacement capital S. Final velocity and displacement capital S. Capital S. Capital S. Then sir, let's find the final velocity. I know initial velocity u, 20 ms minus 1. I know acceleration, 2 ms minus 2. I know time taken. I know 3 variables, u, at, I know. I want to find the final velocity v. What is the best equation? Right now there are 4 equations. I know u, at, I want to find v. I know u, at, I know u, at, I want to find v. Best equation is, remember, v equals u plus at equation. Best equation, v equals u plus at equation. Substitution. I want to find v, u means 20, acceleration is 2, time taken is 20. 20. If you subject, when you subject v, that's going to be here 40 into 2 is 60 ms minus 1, 60 ms minus 1. And now I know v also. Now I know v also. Then they are asking capital S. To find capital S, I can use any equation involving S. One can apply this equation. If not, one can apply this equation. If not, one can apply this equation to find the displacement S. So I am doing, if I do it, if I apply it, S equals ut plus half at squared equation. If I apply S equals ut plus half a t squared equation. Then we can write down display. I want to find capital S only. I want to find capital S only. U is how much? That is 20. Time taken is how much? Again 20. Plus half. Acceleration is how much? That is 2. Time taken is again 20 squared. Simplification. 20 to 20 is, I think, 400 plus these two cancel out. Again 20 squared is 400. That's going to be finally 800 meters my displacement. That's how we are applying linear motion equations. That's how we are applying linear motion equations. I think today we talked about distance, displacement, speed, velocity, acceleration. And we talked about average speed and average velocity. Then we talked about linear motion equations briefly, but I think everything is very clear. Everything is very clear, right? Everything is very clear. I hope that everything is very clear. I hope that story. I hope everything is very clear. Right, Ni? All right. Right. Okay. So then, sometimes today evening we have the class at 6 p.m. our usual theory class. Today we are starting a new chapter. Sometimes I will do some projectile motion questions for 1.5 hour maximum. Then I will start motion graph section, new section. Today we are in the class from 6 to 10, 15 maximum. Today evening we are doing. Therefore, don't worry, we can do story. Again, not tomorrow, again Friday, I can't confirm the time. Friday, I will put a small session and I will complete some questions in linear motion section and I will start explaining vertical motion theories. So today, we'll stop our session for now. Right, with this knowledge, refer once again, try to do the remaining 2 questions. If you're having doubts, ask. And then join for today's theory class for sure and cover it. Don't load the recordings, then at the end you won't have the time to watch the recordings. Then today we can end our session. Then have a good day everyone.